Hello guys, so today I'll be talking about generics in Kotlin. Generics in any of the type languages plays a very important role. Generics makes it much easier for us to write code. It makes the code very explicit. Whenever we're writing code using generics, we get a lot of hints that what should be the proper types, which prevent us from a lot of runtime bugs and all. So the underlying concepts of generics in any of the type languages, right, they are mostly same, and the concepts which we have in generics in Kotlin are very similar to the concepts that we have in Java, but there are few semantic differences between Java generics and Kotlin generics. So let's see that what we'll be covering in this video. So we will look into the simplest generic types in Java and Kotlin, which will give us an idea about what are some of the simple differences between both the languages. And there are three types of different variants which we see in generics, and that's also true for other type languages. So the first type is invariant types. So we'll see that in Java and Kotlin both, like how do we write the invariant types in both of them, and also covariant types and contravariance. Whenever we are using covariant types or contravariance types, we mostly use them in get output context or in context of producers and consumers. So we'll try to understand that when to use covariant types and when to use contravariant types. So again, a lot of these concepts are same between Java and Kotlin. So we'll try to understand these concepts and look at both the codes of Java and Kotlin both. So we'll take an example of a class hierarchy. So at the top level, we have mammal, and then we have animal, which extends from a mammal, and then we have a dog, which extends from animal. So let's look at the Java code for all three classes. So we have three classes. First is mammal, and mammal has an eat method, and extending from mammal is animal. So animal extends mammal. So these are all Java classes, right? And animal has make noise method, and then extending from animal, like the dog extends animal and has a bark method. So let's see how do we use generics in both Java and Kotlin now. So let's see Java code first. How do we use generics? Now we'll be passing one of these generic types to dog, to this generic dog, and let's see, right? So we say generic dog do something. So now since it is of a type dog, it will just accept a dog, right? So I can just pass in dog here, and if I try to pass mammal, it would complain, or even if I try to pass animal. So we could use animal right here. So this is like instead of generic dog, this is generic animal now. If it is of a generic type animal, right, we could pass an animal or a dog, right? So both. But if you pass mammal, so it would complain because mammal is not an animal, right? But a dog is an animal. So this is how like the bare minimal generic types in Java. Let's do the same in Kotlin. So let's copy paste the same code, and hopefully IntelliJ should help us in converting that code. So here IntelliJ has converted that code. Let's take the main out because it doesn't need to be static. Let's remove the companion object, and let's remove the package because it's a different package. And let's import animal. This is mammal. So if you see, it's exactly in the same way like we did in Java, right? And here generics would be animal. Just like we did in Java, we declare a generic class, right? And we declare a do method, like do something, exactly in a similar way as we did it in Java. So let's compare them side by side. This was a generics, right? So exactly in the same way, generic type T and all, just a bit semantic difference. But even here, like when we say do something, it's an animal. If we try to pass mammal, it's going to complain that mammal is not an animal, right? But if you try to pass animal and dog, it would work fine. So on the basic level, both Java and Kotlin, like the generics, work in the same way, right? Uh, just a bit of semantic differences and all. So let's look into some of the advanced types, which are invariant types and covariant and contravariant now. So first is an invariant type. So let's remove this and say generics and type of a string, right? And then we say generic. If we see this, we will not be able to assign a generic animal to a generic string. And the reason for this is there's nothing common between an animal and a string. They both extend from object, but apart from that, there is nothing common, right? So exactly in the same way, Kotlin would also complain, right? So if we say generic string, and now if we try to like maybe, yeah, I will just add it as a type, and we don't need this, right? And if you try to assign a generic animal to it, it would complain because the same thing, because it required a generic string, but we give a generic animal. So whenever there is no common hierarchy, it is called invariant types, right? So there's nothing common in it. So let's look at the next type, which is covariant. So let's take an example here that we want to create a function. Let's do it for Java first. So I'll just remove the invariant type, and we have so here we create a list of mammals, also animals and dogs, right? So here we have a make noises method. So we accept a list of animals and we call a.make_noise, right? So suppose we want to call make noises, right? Uh, and I will maybe just remove the generic type from here. From here, I'll remove this method. We'll just have make noises. And I will just say make noises, right? So we pass list of animals, which works fine now, and we also want to pass dogs, right? But it is complaining that it requires a list of animals, but we are passing a list of dogs. Java is quite strict about it. So, but it also acknowledges these types of scenarios in which we have to accept a list of a super type. So to do that, we would say extends, right, animal. So now it takes dogs also, because dogs are also animals, and it takes animals also. Since mammals are not animals, right? So it would complain about it. But by adding question mark extends animals, we have declared that anything that extends animal, we should be able to take it, because we are ultimately using a method on top of animal, which is make noise, right? So the make noise was inside an animal. So this is how we could declare covariant types in Java. Again, the same thing could be done in Kotlin, and let's do it. Let's copy the code again, and Kotlin IntelliJ should help us. I would just remove this. So there could be better ways to create lists and all, right? So maybe let's do that. So if in this case, if we pass animals now, this works. And if we pass dogs, this still works. So Kotlin compiler is smart enough to see that dog extends from animal, so it will allow it to work, right? So so we don't have to declare any special types like the way we were declaring in in Java, right? So let's again compare this. We had, if we say dogs, so here we had to declare like question mark extends animal and all, but in this case we didn't have to, right? We just declare list of, it's taking a list of animals. So Kotlin is smart enough to just figure out the covariant types and make it work for us, right? So again, like we pass a list of dogs and it works. We could do, like we could just say out to be specific, but it is not needed. So just like we say question mark extends, an equivalent to this is an out type, right? But again, like as we see, like we don't need this. Kotlin is smart enough to figure out the covariant types. So let's look at the third type, which is contravariant type. So let's try to sort the list of dogs. Dogs.sort, and takes a comparator, right? So comparator and so let's not use lambda, then I'll keep it simple. Right now I just declare 0, everything is 0, but we can have some logic, right? Maybe based on dog name and all. So right now, like if we see sort, it accepts a comparator, right, of anything which is a dog and anything that is a super of a dog as well, right? So whenever we declare that we accept any of the types and super types, we count that as a contravariant type, right? So in this case, like we can use a dog comparator, but we could also use an animal comparator. So just like we're passing dog comparator, we could pass animal comparator. And the reason it is very logical in this case to make it work for animal comparator is because, like, suppose we're sorting a list of dogs, definitely they're all list of animals as well. So if we're able to sort list by dogs comparator, we should be able to sort them by animal comparator also, because they're ultimately like all animals, right? So the sort method enables us taking a contravariant type for comparator, which declares that it would take anything of a super type of a given type, right? So in this case, it could, like, to sort dogs, it takes a contravariant type of a comparator, which is also dogs comparator and also the animals comparator. So the same could be done in in Kotlin as well. So let's do it. So here when we see with, right, so we have, it takes a comparator, and comparator we have in. So just like we talked about, when we use question mark extends in Java, we can use out, but in case of like whenever we have to declare question mark super, we can use in, which is a specific, like which is which are semantics of Kotlin. Right? So here we could pass an animal comparator, or we could pass a dog comparator, because the type here is dog, right? And in means anything which is inside of a dog, right? So animal is inside of a dog, right? So it is inwards towards it. Similarly, out was outwards, like outward of dog is an animal. So these are on a high level how what invariant, covariant, and contravariant types are, right? And let's try to understand that in what cases will we actually use covariant and contravariant. Covariant is easy to relate, but contravariant is sometimes difficult. But let's look at those rules. So let's take more examples to understand how covariance and contravariance works. So let's take it in Java first, and then we'll do it in Kotlin. So if you see in this example, we are using covariance type of example, right? So we take a list that is declared as covariant. So it accepts any, like a list which has animals or anything below that, right? Even if we know it has animals or anything below that, right, it won't allow us to add either dogs or animals or mammals, right? So, and the reason that is because it doesn't know like what is the concrete type, right? But if we try to change it to super, right, and if we see now, right, it is a super of animal, right? So we could add like dogs also to it, and also animal. Whenever we have to use like put something to it, right, in case of a put we use contravariance. In case of a get, right, like again, like let's go back. So let's take the example of get. So we do the same thing, add to a list, okay? Say get from list. So when we get something, we see here that we get a type of an animal, right? Basically, whatever type we declare, we'll get the same type back. So if we say dog, right, we definitely get an animal here, right? But now I could just say type of a dog also, and then I could call like dog methods on it, dot bark. So when you're getting something out of it, we use covariant type. Whenever we're using putting something, we would declare contravariant. And let's see the same thing in Kotlin. And we'll also take one more example, which will make things a bit more clearer. So here we have a mutable list, right? Just like this is type of in. In stands for contravariant, right? In this case, like out is not required. You could still say out of, like maybe in this case animal, right? So animal 0, it returns like a type of animal. So covariance works by default. So in these cases, we don't need to declare out in Kotlin, but like in, so if you see here, we are able to add the elements just like we were able to do that in Java. We're not able to add mammal here, but like at least anything animal or below that. And we could also see by out, and you'll see like they all fail now, right? Because again, this is in case of a covariant type of a list, we can't add anything. So a perfect example for that is function copy. So if you see here, this is how we copy. Again, this is redundant whenever we use out because Kotlin figures it out by itself. But so destination always has to be an n, right? So in this case, it was an animal, and we could just copy like dogs and also animals and all on it. So let's see the example here. So we could say, so we declared copy here, and let's just use the copy method. So we say g.copy, and the source could be animals, right? So, and the destination could be mutable list of animals, right? So this works, and same we could do it for dogs. So we could say dogs, and this again works, but we will not be able to do mammals because it is not type of a animal, right? So again, this is, we see a concrete example where we are using covariance and contravariance both. And this is where, so again, the rule is whenever we have a consumer, right? This is a consumer, this is getting, like we're putting animal into it. So we use contravariance here. Whenever we have a producer, in a producer, we use covariance. Same as for get input. In case of a get, we use out. In case of a put, we use in. Put means in, and get means we are getting out, right? So again, so that it is easy to relate. So I hope this makes generics clear for you in Kotlin. Again, like the concepts are very similar in Java and Kotlin. It is more of a generic concepts, right? In any other type language. But as we saw in Kotlin, like the covariance and all, it works very nicely because we don't need to explicitly declare animals and all here, right? So as we saw, like for make noises and all, right? So we could just pass animal and dogs also, animals and dogs also, which was not the case in Java. Yeah, so that's it for generics.